Now, one of the most difficult concepts for people in this second unit of physics is the idea of momentum. Now, it's a difficult topic for a couple of reasons. But firstly, some people struggle to understand what it means. Crudely speaking, momentum is how difficult it is to stop something. Now, if you imagine I throw a tennis ball at you, it's probably fairly straightforward for you to stop it. If I drive a double-decker bus at you, it would be remarkably difficult for you to stop it. The bus has more momentum than the tennis ball. Now, there are two things that momentum depends on. I'm going to use the letter P to represent momentum, and momentum is equal to the mass of an object in kilograms, which is why a bus is more difficult to stop than a tennis ball, multiplied by the velocity of an object in meters per second, which is why a tennis ball at 70 miles an hour is significantly more difficult to stop than a tennis ball going at 1 meter per second, perhaps. Now, you'll notice the units there of mass, a kilogram, the units of velocity in meters per second, which gives us a unit for momentum of kilogram meters per second. And that is definitely worth learning, because it's very common that examiners will ask you to give that unit for momentum. So it's really easy to calculate momentum, just mass times velocity. Really straightforward calculation. It's how we use that value that can get a little bit trickier. Firstly, a favourite examiner's question is to ask you about safety. If you imagine that you fall off your bike and your head is about to hit a surface, what kind of surface would you like to hit? Would you like to hit hard concrete? Would you like to land on a well-placed pillow? Now, it should be fairly straightforward, the choice. You're going to choose something soft. But why is that? Well, the answer is, if you land on a pillow, you are increasing the time of impact. And if you increase the impact time, that has two effects. Firstly, it reduces the rate at which you lose momentum. So if you hit a pillow, you lose momentum more gradually than if you land on concrete. And that in turn has an effect that it changes the size of the force, and you end up with a smaller force of impact. So increasing the time of impact reduces the rate of momentum lost and reduces the force. If you want that as an equation, I can say that a change in momentum is equal to force times time. So for the same overall change, a big force happens in a short time, or a long time requires only a very small force.